Okay, we're going to be looking at magnetism for a bit here, and I wanted to ask, what is a magnet? Is it something natural or is it something man-made? So the answer to that is it can be either. The earliest magnets, like there are rocks that we can dig out of the ground that are called magnetite, and they are magnets just from when you dig them up. So the earliest experience with magnets was probably with magnetite, and so people found that there were some unusual properties of magnetite, and then we've developed, and now we have man-made magnets that are a lot more effective than just the magnetite, are a lot stronger. So, magnet is something that has two poles to it. It has two opposite poles, a north pole and a south pole to it. And we find that if you take a magnet and you break it in half, you might think, well, okay, now I have a north pole side and a south pole side. But when we break a magnet, we find actually the broken side is going to become the opposite of the other end. So if this was the north pole, breaking it makes two smaller magnets with a north pole and south pole each. So then if I put a north pole near a south pole, then they're going to attract one another. If I put a north pole near another north pole, then they're going to repel each other, and they don't want to stick together. Okay, so so some magnets can be what we call permanent magnets, and that is that they, somebody magnetized this magnet here, and for years it stays a magnet. Other things are temporary magnets. Maybe they can be magnetized for a little bit, but then after not very long, they just lose their magnetism again. Okay? Things like, you might have seen before, if you take a nail and you rub a magnet on the nail, you can get that nail to become a magnet for a while. And so it can easily turn into a magnet and pick up a staple or a paper clip, but then after not very long, it's going to stop being a magnet, and so it'll lose its magnetism just as quickly as it got it. An iron nail can become magnetized, and we'll say that it is a soft magnet, a soft permanent magnet. There are other things that can become magnets as well. We have cobalt and nickel are the other two common things that can be magnets, and those are much harder to magnetize, but once they are magnetized, they don't tend to lose their magnetism very easily. So we'll call those hard permanent magnets. Okay, so then we'll say, when I have a magnet, we're going to say there's a magnetic field that surrounds this. This can give a magnetic force on something else. We saw just a moment ago that there's a force here. If I try to push these together, there's a force that's pushing back that doesn't let them touch each other easily, or in the other direction that pulls them together. So we've got these magnetic fields surrounding it, and inside of things that are magnets or that are magnetized, we tend to find what we call magnetic domains. We have different atoms inside that are grouped together with other atoms nearby that are lined up so that their magnetism is facing a certain direction. So if we go back to our nail, if I take a magnet and I rub a nail with the magnetic domains inside get pulled so that their direction of magnetism is lined up along the whole thing. And then now that nail is a magnet. If it gets dropped or it gets jostled around, or if it gets heated, then those magnetic domains will go back to being kind of randomly arranged. So a random arrangement there would make it so that that nail is not a magnet anymore. So it still has magnetic domains inside of it, but since they're all in random direction, there's no overall force from that one. Okay. So we've got magnetic field that surrounds our magnet, and lots of times we will represent that with magnetic field lines. So if I drew this magnet, I might want to draw the magnetic field lines, and so I'd say, okay, I would draw them coming out of the North Pole, curving around, and going into the South Pole. And every magnetic field line is going to form a loop. And when we're trying to represent this, when we show it on a piece of paper, we'll show that places where those magnetic field lines are close together are going to be where the magnetism is strong. Where the magnetic field lines are more spread out, that's going to be where the magnetic force is weak. So, so if I take one of my magnets and I hang it from a string, what do I find? I find that it tends to line up in a certain direction. So why is it that it wants to line up this way? If I turn around, does the position of the magnet change? No, it just stays there. So the Earth is also acting like a magnet. If we were to look at the Earth's magnetic field lines, there would be a magnetic field line that's passing straight through this magnet. So people noticed that magnets tended to line up north and south. So since this direction is north, we call this the north pole of the magnet. We could call it the north-seeking pole of the magnet and the south-seeking pole of the magnet. So I can hang that and it becomes a compass. If we think back to how our magnets interact with other magnets, this is the north side of the magnet, the north pole of the magnet, and it's pointing to the north. So if I went to the Earth's north pole, what would I find there? Is that where the north magnetic pole of the Earth is? Well, since the North Pole is being attracted this way, that means actually the Earth's south magnetic pole is going to be what we find at the North Geographic Pole. So it's kind of different. So if we drew a picture of the Earth and wanted to draw magnetic field lines, we would draw them coming out of the North Magnetic Pole in the south, in Antarctica, and curving around to the North Magnetic Pole that's near northern Canada. Okay, so then why is it that the Earth is a magnet? We don't know. So Scientists don't really know why Earth acts like a magnet. It's a good thing it does because it protects us from charged particles that are flying through space. It kind of makes a blanket around the Earth that shields us from stuff that can kill us. But why is it a magnet? We don't know. Have we ever dug down to the core to see what's down there? No. The closest we've gotten, we've gone down 13 kilometers as the lowest that humans have ever dug through the crust of the Earth. That didn't even get us to the bottom of the crust. It's like if the Earth was an apple, we started to make a hole through the skin, but we didn't get all the way through the skin. So, we've never been to the core of the Earth. Geologists will say that it is made of iron and nickel mixed together. And the only reason they say that is because iron and nickel are both magnetic, and the density of that core is halfway between iron and nickel. So they said, okay, maybe iron and nickel. Do we know? No, we're not confident at all. But that doesn't stop us from saying in astronomy that all the other planets in our solar system also have nickel iron cores. So that's a bit about our magnets to get us started, and then I'll have an assignment here that you can take a look at and show me what you can do from there.